Mirror notes. Different types of reflections. A specular reflection is a reflection from a smooth surface. Normally, a specular reflection would be something that you would see off of a mirror or off the surface of a water. Anything where you can see a reflection or see yourself in, that is called a specular reflection. The other type of reflection is called a diffuse reflection, and it is from a rough textured surface. Example is a textbook is red because the textbook reflects red light. White light is mixture of all the colors of the rainbow. When we shine white light on an object that is red, the red light reflects off of it. All these other colors get absorbed by the red book. This is the reason why we see red, is because the red light reflects. If we shine just red light on the book, red books reflect red light and we will still see the book being red. However, if we shine blue light on an object, red objects absorb blue light, no light will come off, and the book will look to be a dark gray or a black. So here's our example. With white light on our physics textbook, you can see the red background here, and we can see the white parts of the writing. When I switch the light over to red, we no longer see the writing. The red part is reflecting red, and the white part is reflecting red, and it all kind of blends together and makes it look like a red reflection there. When I switch the light over to blue, the red object is absorbing the blue light, and you see the color black or a dark gray, but the white writing on the book still reflects the blue light. So we're seeing blue writing on a black background. And same if I put green light on there, the red object absorbs the green light, so you're seeing again gray or black, and the white writing reflects the green light, so we're seeing green writing on a black background. So those are all called diffuse reflections. All right, pause and copy. Next topic is the law of reflection. When we're drawing a picture of a mirror, the computers are nice because they can do this gradient color on the side. The way you're going to draw a mirror is drawing in hash lines on the back side. So the smooth side of the mirror is the reflective side, and the back side of the mirror is the one that has a shadow on it. So we're going to shine a light ray onto a mirror. A light ray coming in is called the incident light ray. We remember it because it starts with in. That's the incoming light ray. Right where the light ray hits the mirror, we're going to draw an imaginary dotted line called the normal. Then the light ray is going to reflect on the other side. We call that light ray the reflected light ray. So this is the incident light ray and the reflected light ray. Now the purpose of the normal line is to measure this angle of the light rays. The angle on this side is called the angle of incidence because it's from the incident ray to the normal. The angle on this side is called the angle of reflection, and it goes from the normal to the reflected ray. Now, the law of reflection says the angle of incidence is equal to the angle of reflection. These two angles are always equal to each other in every reflection. Pause and copy. A flat mirror is called a plane mirror. In physics, we call it a plane mirror. And we're going to write down some rules for drawing the light rays on the plane mirrors. The first rule says light coming in parallel to the normal reflects along the same path. The second rule says light coming in at an angle reflects at the same angle. So let's draw our mirror here. We have an object in front of the mirror, and I'm going to do my light rays from the tip of the pencil, and the goal is to figure out where is the image going to be behind the mirror. So my first rule says light coming in parallel to the normal. It's coming straight into the surface or perpendicular to the surface, and it's going to bounce back along the same path. The second rule says light coming at an angle. So I'm going to start the light ray at the same point. It's going to come up to the mirror, and right where the light ray hits the mirror, we're going to draw the imaginary normal line, and we're going to measure this angle and measure that angle, and it's going to reflect at the same angle. That's the law of reflection here. So these two light rays are not crossing each other. What we're going to do is trace them backwards behind the mirror. These are called light ray extensions. And right where the extensions cross each other shows exactly where that pencil is going to be behind the mirror. That is our image. When you're looking at something in a mirror, you're looking at an image. Things we can measure on this, we have the distance from the object to the mirror is called DO, and the distance from the image to the mirror is called DI. And for a plane mirror, those are always equal to each other. The distance of something behind the mirror is equal to the distance of something in front of the mirror. The other thing we can measure on this is the heights. The height of the object is always going to be equal to the height of the image for a plane mirror. Pause and copy. All right, next section is types of images. There's two types of images that we need to have memorized. First one's called a virtual image. A virtual image is what you see in a regular mirror. Virtual images are behind the mirror. It appears that this object is behind the mirror. Virtual images are right side up, and they cannot be projected onto a screen. And these definitions we'll understand later on when we get to the other types of mirrors. For right now, it's just something we have to memorize. The other type of image is called a real image. The real image is in front of the mirror, it's upside down, and it can be projected. Whenever you see something being projected onto a screen, that is a real image because it can be projected. The image is supposed to be upside down, and of course this isn't upside down. What happens when the teacher is using the overhead projector, he has to stand on the back side of the machine and write upside down, so when it projects it on the screen, it comes out right side up to you. The same principle is true with the old-fashioned movie projectors. You can see the film going through the projector here. That film has to be upside down. The pictures have to be upside down, so when it projects on the screen, it flips over and becomes right side up. Same is true with the old-fashioned slide projectors. You put the slide in upside down because it has to flip upside down when you project it. That's what a real image does. Pause and copy. End of notes.